question here is, are children with higher exposure to pesticides more likely to develop ADHD? So there's a study done where the authors measured levels of urinary dialkyl phosphate, or DAP, concentrations, and ADHD diagnoses were looked at for 1,139 children who were representative of the general U.S. population. They're divided into two groups based on their high or low pesticide concentrations, and then they compared the proportion with ADHD in each of the groups. Okay, so we have two groups, and we're looking at, for each of those groups, what percentage have diagnostic case of ADHD. We want to define the relevant parameters and state the null and alternative hypothesis. So we usually look at like P1 and P2 if we're comparing proportions, because when we have yes-no data, this is categorical data. And when we're dealing with categorical data, that means we look at proportions instead of means. Means are useful for quantitative data. So we have these two groups, and we're looking at categorical data and comparing their proportions. So instead of using P1 and P2, the 1 and 2 are just placeholders. We could also do something like the proportion from the high group with ADHD and the proportion from the low group. And we compare these by checking if their difference is 0 or equivalently that they're equal. So now, when we think about the direction that we're looking at for the study, we wanted to know if higher exposure was more likely to develop ADHD. So if higher exposure is more likely to develop ADHD, we would expect the proportion for the high group, H, to be higher than the proportion for the low group. So our direction here is if this difference is positive. This next question I usually ask my class to just sort of think about. If I have 1,139 children and I'm looking at a difference in two percentages, how big would you expect that difference to be for you to start to say, yes, like there's actually a difference? And so I ask them if 20% is big enough, and they say, yeah, like 20% is a pretty big difference. What about 1%? They say, no, that's not really substantial. And we kind of go back and forth. And then 10% and 2% and so on. And so for most people, we say that with a pretty large sample of 1139, as soon as we got a difference of around like 5%, that is where we start to think that, like, yeah, that feels like a difference. So for this, I'll just say, since we have a fairly large sample, and we probably need a difference of at least 0.05 or more for us to feel like, yeah, that's actually a difference in those two proportions. So a difference of at least 5% between the pH and PL values that we would get from the sample. So pH hat and PL hat. The next page then asks a couple other questions here. So to assess the statistical significance, we assume the null is true, and we try to see if we have evidence in contrary of that. What would that mean in terms of the study? So if the null is true, then pH and PL are the same value. And so that what that would mean in words is that there is no difference in the population proportions of kids with ADHD, which is what we were looking at as our data, for the low versus the high pesticide. Okay, so the null suggests no difference. If the study found that the results were statistically significant, what would that tell us? So what we were saying as our alternative, which would be if we had statistical significance, we'd go with HA, the alternative, that would tell us that the population proportion of kids with ADHD is higher for the group with high pesticide exposure. So these two parts here are really putting into words the symbols that we put in the null and in the alternative.